One thing that is going to be a new addition for us this time through, for many of us, is we're going to go and we're going to talk about what they refer to as unit vectors. Okay, and so what we get is that the unit vector will be unit magnitude, the magnitude's 1. There are no dimensions or units on my unit vector. It's just the length is 1, mathematically 1. Okay, and it will point in the direction of increasing value along the axis, under consideration, whichever axis that happens to be. Okay, and so one thing that we should point out is that, and I think I mentioned this already, for a three-dimensional coordinate system, it must be right-handed. Okay, so that's a convention that has been already selected, and so we have to maintain that choice. And so what you get is you get the right-hand rule. I always call this one right-hand rule number 1. Okay, and what you get is that you have the fingers, the direction of your fingers when they're extended, the direction of your fingers when you bend them, so as if they come out of your palm, and then the direction of your thumb. Okay, and what this gives you are 3 mutually perpendicular directions. Okay, fingers, palm, thumb type of thing. So that's how I usually label these. Fingers, and this would be out of the palm, and then your thumb. Again, it has to be your right hand. It can't be your left hand, because no matter how you rotate your right hand, you can't get it to be the same as your left hand kind of stuff. Okay, 2 will agree, and then the other one will be opposite, no matter what. So the thumbs are the same direction, the fingers are the same direction, but out of the palms are in opposite directions. So then if I fix the fingers and the out of the palms are the same direction, now my thumbs are in opposite directions, and so on and so forth. And so, there are right-handed and left-handed coordinate systems, and we need to make sure that all of our coordinate systems that we use are right-handed. And the way that this goes with our fingers, palm, thumb type of right-hand rule, and there are variations on how to do the rule, but this is the one that I think is the most general, is you do alphabetic order. So you do X, Y, Z. Okay, and so then when we come in and take a look at our coordinate system, then one way to draw this is to draw it with this kind of perspective view, like so, where this axis could extend back this way, this one would extend over to the left, and this one would extend down. And so this makes our coordinate system, and we need to make sure that it's going to be right-handed. Okay, did we already talk about handedness in coordinate systems? I can't seem to remember if I already did that here or not. Okay. So I think I just mentioned it had to be right-handed. I'll bet that's what I said. All right. So what this means is, in order to generate a right-handed coordinate system, we get to pick any 2 axes to be whichever way we want them to be. There are 2 very common choices And so we'll go over those. But one of them is to kind of make it look like what we were doing in a two-dimensional coordinate system where, you know, this direction is the X and then this direction is the Y. And then we can determine which way is the Z, whether it's out of the page or into the page is the positive Z direction. So in order to do that, you take your right hand, put your fingers in the direction of the plus X direction. And now notice that I can rotate my hand and I can rotate it so that the Y's point out of the palm. So I get my fingers out of the palm and then my thumb points out of the page, which would be this direction for our positive Z axis. Okay. So this is one very common coordinate system that is done. So X, Y in this plane of the page, and then Z goes in and out of the plane of the page. Another option in terms of how to draw these, instead of doing a perspective diagram like this, which can be a little challenging to draw and to interpret when you first start, is that we could also go in and talk about them as physical, as the vectors as being physical arrows, right? And so if I pretend that my little marker is the arrow, okay, so then this is the tip of the arrow, this would be the tail, this would be where the little feathers would be on the arrow itself. Then if you take a look at it as if it comes out towards you, then what you see is you see the tip, okay? And so what you get is, if we want to draw something that is out of the page, then we draw either the tip of the arrow or either a dot or a circle dot. So they either draw dots or they'll draw dots with circles around them. Again, trying to essentially look at the fact that it's the tip coming towards you, and they either just write the dot, but sometimes that's hard to pick up in the diagram, so sometimes they'll circle around it, you know, being the shaft of the arrow as well as the tip of the arrow, kind of things going on. So this would be out of the page, okay? And then we can go in and take a look at what would happen if it goes into the page. I think into is, that'll be all right. We'll just leave it like that. So we go into, then what happens is that you see the feathers on the arrow as it heads away from you. And so then they draw those feathers as an X. So these are the fletches or the feathers, or they'll put a circle around it. So it's either an X or an X in a circle. And so those are the, again, this is the tip of the arrow heading towards you, coming out of the page. And these are the fletches or the feathers. Going away, okay? And so another one that I often do is I'll often pick that, this horizontal plane, this would be your X and Y, and then we could figure out which way Z goes. And so we could state that, well, what if we pick that this direction is plus X, and then this direction is plus Y, and then Z is either up or down. And again, we would use our right hand rule. So, put the pen down, put the pencil down, and you're going to go in and put your fingers in the direction of the X axis. So coming out of the page like this. Notice I can turn my hand, well, I'm going to turn the page because my hand doesn't work very well. I can turn my hand so that out of the palm points in different directions. And what we want is we want the fingers in the direction of the plus X, which is out of the page. We want the out of the palm direction to be in the plus Y, and then our thumb points in the direction of plus Z. So it will go, up on the page. Okay. And so this is how we would generate a three-dimensional coordinate system. We can do this kind of in and out and then work with the plane of the page, or you can do this kind of perspective diagram. Takes a bit of practice, but we could do that. Now, what we're getting to are these unit vectors, okay? And so if we go in and look at our coordinate system here, then we'll have a unit vector that points in the direction of increasing X, so in the positive X direction, okay? Now, standardly, what they'll do is they'll mark this as I hat. Okay, so usually put a hat on top to indicate that it's a unit vector. So this is an I with an extra line to make it a vector, and a hat to indicate that it's a unit vector. Points along the x-axis in the direction of, positive x. And then you'll have a unit vector, magnitude of 1, no units or dimensions, and this will be j hat along the y-axis. And then along the z-axis, so this kind of out of the page direction, this is going to be k hat. So I hat, j hat, k hat will be the unit vectors. Okay, and again, magnitude of I hat is just 1. Magnitude of j hat is 1. Magnitude of k hat is 1. And so I, j, k are very commonly used. I've also seen things like x hat, y hat, z hat. So that's another option in terms of things that you might end up seeing. X hat, not z. Let me start off with the first one. So we would get that this could be, x hat, y hat, and z hat. Other notations in mathematics that I've seen would be things like a unit vector or basis vector. They usually use a lowercase e with or without a hat. And then they'll label it as an x. I'll put the hats on. So you could get ex, ey, and ez. So these would be basis vectors or unit vectors and along the x, y, and z directions. That could be another option for notation that you might have seen in a math course. So these are all pretty common. We're going to stick with the IJKs, are the ones that we are going to do. And so then when we go in and we take a look at our vectors, so if we take a look at vector A, then we could write this as being our AX vector added to AY vector added to, let's say, AZ. We'll include a Z component. We won't do much with Z components, but every now and then they will pop up. So it's good to get used to those. And so then what you have in this instance is that these quantities are your vector components. Okay. They themselves are vectors. They have a magnitude and a direction. Okay, and then we could also write them using our unit vectors as follows. So then this would be AX in the I hat direction, and then this would be AY in the J hat direction, and then this would be AZ in the K hat direction. So these are our unit vectors, I hat, J hat, and K hat. And then these components that sit in front of those, this AX without the extra line, and this AY without the extra line, and the AZ without the extra line, these are the scalar components of our vectors. And so AX, if it's positive, will point in the plus X direction, but AX, if it's negative, will point in the negative X direction. So that kind of idea. And then the beauty of using these unit vectors and working in this unit vector notation is that if we want to go in and calculate, vector A added to vector B, okay, then what we would do is we would rewrite this as being our AX in the I hat plus our AY in the J hat direction added to BX in the I hat plus our BY in the J hat direction. And then what we can do is we can collect like terms. So I have I hats and I hats. I can put those terms together. And what you would get is that this would be AX plus BX. This is in the I hat direction. Okay. And then I have J hat and J hat. I could collect those as like terms. And what I'll get is that this will be AY plus BY in our J hat direction. And so therefore we've now added the vectors using our unit vector notation. And again, you see that we get to the same kind of thing where we have x's with x's and y's with y's. And then, we would recombine to get our final answer as needed. Okay.